Okay, now we'll start discussing related to thread object. Okay, actually, actually, thread algorithm is nothing. We know that thread is nothing but the execution of the code. So, before creating the thread, we have to know that this thread need to execute which code. You got it now my point. So, thread object actually for execution of the code. To execute the code, we have to define the code before. So the my point is, so what is my point is, I'm saying that we are creating the thread object. Thread object is nothing but execution of the code. So execution of the code, which code the thread object need to execute. That's why we have to define the delegate. Or one second. Okay, sorry. Okay, so what I am saying that thread is for execution. So before creating the thread, we have to define the code execution. That's why there is a delegate thread object encapsulate delegate. This is the code which is run by this thread, which is executed by this thread. Okay, the next question arises is, who is the creating this thread? Actually, whenever we are executing the code .exe, this is by default by the process. To that process, main thread is there. Main thread is executing this main code or other main code. But now we are creating ourselves thread, so we itself create the thread object and we encapsulate the delegate. But who will run this thread? Actually, main thread is run by whom? This is run by the processor. So there is a control in our hand when to run this thread. I will explain laterly. We have thread pool is there, that concept. But now this thread is run by us. So what is the method to start execution? To start executing the code, whatever it is encapsulated in delegate is, so start method. Whenever main thread creating the thread and start this method, then it is start to running. So this is the main thread, this is the sibling thread. So this is the topic. This is the point I need to say. Next thing I need to describe, starting of the thread is completed, then end of this thread. Who will end this thread? So that means there is a lifetime of this thread. Lifetime of this thread. One is start and end. Before going to the lifetime of thread, I have whatever thread I am created. There are different types of thread. Mostly two types. One is foreground thread. One is background thread. If we explicitly created the thread through new keyword, this thread is foreground thread. By default, foreground thread is there. By default in thread pool it is created a background thread. Then the main differentiate is if application contain multiple background threads and only one foreground thread. If this foreground thread lifetime is completed, then by default application will close. Instead of waiting, there are background threads are running in our application, and the whole lifetime means closing of this background thread is completed. Closing of this background thread, then only our application will close. Like that means stopping of this background thread, then only our application will close. Like that we are differentiating based on the closing of the application. So minimum main thread or foreground thread required to the process to run. If there is background thread is there without foreground thread, then application will close. Means by default background thread also close. You got it now? The lifespan is a background thread is dependent on foreground and main ground thread. Okay, and next thing I need to discuss is suppose this is main thread and this is sibling thread and this is foreground thread only. Whenever exception it happen here, how it is handling, that's the question. Next thing is whenever the suppose this is the foreground thread encapsulated the delegate. Okay, this delegate execution is completed, then who will kill this foreground thread? Either we are explicitly killing or who will kill? That's the question. So this is the thread which we created through new keyword, and this thread encapsulates the delegate, and we are saying that thread this start, this method is saying to the CLR that you need to run this thread. Okay, so whenever delegate execution is completed, CLR itself clear this thread, remove this thread. Whatever the resource used by this thread, CLR will clear those resources. So CLR take the responsibility. Now next thing is Mr. This exception is happen, how and who is handling. This is the thing I need to discuss elaborately. So whenever exception is happen this thread, we have to write try catch block. Here exception is handling. If try catch block is not written, then what happens? In this in worker thread, it is check all stacks. Is there this stack? Is there this stack? Is there this stack? Any one stack it will be handling. It is checked. If nothing, any stack is not handling, then what it is doing is CLR will terminate this thread. My point is that CLR will clear or clear the thread whenever the clean up the thread or terminate the thread. Termination will happen whenever exception is happen in the thread and no method which is available, which is no method of the respective thread is handling that exception, then CLR will, what it is doing, CLR will terminate the thread. And before I had to explain one thing, how it is cleaning CLR. Suppose this is the foreground thread. If exception is happen, CLR will terminate this thread. But before terminating this thread, CLR doing multiple things. What it is doing? First, whatever memory used by this thread need to clear by the CLR. If stack memory is there, which are nothing but the stack trace which is used by the particular foreground thread, these to be clear. And next, some heap objects are there which are referenced by this thread, not other thread, whose scope is dependent on this thread. Those objects to be clear. This clear by the CLR through garbage collector. So first thing, so what it is doing, clearing up the memory. Next it is doing, suppose if any file handling operation is doing by this thread in any respective stack and exception is happen in this stack, no one is handling, but this call stack, it is doing some file handling operation. So what it is doing, suppose it is reading 10 MB and 5 MB is this in, not reading, I can say writing 5 MB it is in buffer. What it is doing, this CLR, whatever data which is available before clearing the thread, if no one is handling, it is still no one is handling, what it is doing, this buffer will dump into the file system data, and finally that dump means flushes the data, and finally whatever logs which is used by the this object, log is file log, those logs are also released, because next one anyone need to use those logs, and if CLR will not release that log, then nobody will access this file. That's why CLR take the responsibility to remove those logs before terminating the thread, and finally remove this, close this object. Okay, what are it is doing? First I say that memory, whatever the memory used by this thread, like call stack and heap, those are cleared by the CLR. Next it is doing, if this object, if this thread in any stack which is doing IO operation, those things also clear. And next is whatever database connection it is there, in it is using by this respective thread in any one stack, if connection is active, it will have to close those connection, because otherwise otherwise SQL which is using this connection, it is thinking that I have already open connection, is there unnecessary SQL memory will loss, and that's why it need to be clear. Suppose sometime we are using the DB context connection object in .NET framework. The DB context connection object is coming from connection pool. At that time it is not clearing the connection object, it is not closing the connection object, but it is sending to the connection pool. Next time some other thread will use this connection object. Finally sometime unmanaged resource are there, those are not taken the responsibility by the garbage collector to clear, those need to be written in this final method. Otherwise it is inherit dispose method, if this disposable method. Got it now my point? And if this thread is using some any logs, those logs need to also be removed, because some other thread will dependent on this log. This logs need to be released, otherwise deadlocks happen. These are the things. So these are the responsibility taken by the garbage CLR. Mostly before clearing the thread, it clear the memory, and whatever it is using IO operation like file IO, connection, streaming, all things it need to be clear. and if unmanaged resource it is using, so unmanaged resource must be written in dispose method or final method, then CLR will call that methods. And finally, if any logs are there, those logs to be released, otherwise dependent other threads which are dependent in this thread, this log will get deadlock. So this is the thing. Next thing I need to discuss is thread dot abort method. Thread dot abort method. After that I have to discuss other things, but I didn't have time. Okay, thread dot abort method responsibility is suppose main thread it is created, sibling thread. Okay, I need to send exception, because it have to close instead of running. At that time I am calling the start method. Like the start method, I am calling the abort method. Whenever main method is calling the abort method, it is throwing the exception in this thread. So this thread retain code in such a manner that not only while this thread bottom stack will handle this exception which is arises by the abort, like that closing we are doing. So main thread will clear this thread by throwing the exception. That's why we are using the abort method. Wow, you got it now? Main thread throwing the exception to the sibling thread or child thread which is created by main thread. Okay, next I have to discuss what are the best practices, and finally graceful shutdown and choreographically shutdown. But I have 2 minutes. Okay, so best practices is first we know that we have to use try-catch blocks commonly. We have to compulsory use the try-catch block to handle that exception. Next is we have to, this is the main part here, we have a app domain which is running the code. Sometimes if exception is not handled in any thread, any stack, then application process, if this thread is main thread, then process manager will kill this process. But we have to know why the application is closed, so where that information will be get. That's why final one place is there, that place is handling of the exception, that place is in app domain. What it is doing is whenever exception is occur, no one is handling, finally this app domain will handle this exception. After handling this exception, app domain will shut down the application. And so from this handling we know we have to log what are the exception which has occurred. We are not yet able to handle that exception, that part we have to log. And from the so best practice is we have to write app domain and handle current in app domain we have multiple current domain, but we have for the current domain where our application is running, there unhandle exception method is there, delegate is there. We have to define the delegate. This is the final place where our application need to be handled. If this place is not handled, then what it is happening, nobody know why the exception is arises. So here we are logging the exception, why it is happen, and which exception we are not yet handling. Finally, I am explaining the choreographically shutdown. This is nothing but from this concept, manual reset, auto reset event is arise. This is the main thread which is started. This is the sibling thread which is created. Sibling, I can say child thread which is created. The main thread. I need, after processing some time, I need to kill this thread. Instead of throwing, I need to stop this thread execution. That's why the child thread encapsulate whatever delegates which will return inside the boolean condition and do the processing whatever it need to do. This boolean is the shared memory, and the scope of this boolean is available to both main thread and sibling thread, child thread, and this boolean is volatile type. I will explain the concept what is the related to the volatile type. And whenever main thread need to stop the execution of this child thread, just update this volatile thread is false. Then after certain duration, this main thread coming to the child thread coming to the while loop, there it will close. It will then identify and come exit of this thread, exit of this delegate. Whenever I get exit of that delegate, then CLR will clear the this child thread, because nobody is nobody is handling the thread. Okay, done. That's it. We'll explain remaining sleep method, alive property, and join method. Thanks.